let us contrast the flow and the pressure patterns in a volume control and a pressure control mode. What happens in a pressure control mode is, well, let's say we have set a pressure of 20 centimeters of water, which is our target. So as soon as the breath starts, the pressure will go up to 20 centimeters of water, will remain for a period of time, which is the I time, which we have set, and after this is over, the breath will go into cycling. So the cycling here is also by time, but there is a different pattern in the flow and the pressure graph. Let us look at the pressure graph in a pressure control mode. From peak, we have set a pressure of 20. So as soon as the inspiration starts, the pressure rises up, reaches 20 and stays at the same level all throughout the inspiration. This can be called the rise time. Again, like in the volume control mode, how the flow rises, how the pressure rises here. The pressure remains constant all throughout the inspiration, and at the end of the inspiration, when the breath cycle, it falls down to the level of the PEEP, stays there all throughout the expiration and starts from there. So we have a pressure pattern in volume control mode which goes up and reaches the peak at the end of inspiration, but here it reaches a peak just at the start of inspiration, stays constant and then drops back to the PEEP levels. How does this change the flow pattern? We know there is a huge difference at the start of the breath itself between the PEEP and the peak pressures. This generates a tremendous amount of flow and volume delivery at the start of the breath itself. So if we look at the flow, it rises very sharply, and because the pressure now remains constant, the flow keeps on decreasing till the cycling point has come, and then the breath goes into expiration. If we contrast the flow pattern, here we had a constant flow because we wanted an assured volume of delivery, but here we have what is known as a decelerating pattern of flow, that the initial flow is very high and then it falls back to the cycling point where it goes into expiration. The constant thing here remains the pressure, whereas the constant thing which remains in the volume control mode is the flow, whereas the flow pattern in a pressure control mode is decelerating pattern. And sometimes this is supposed to be beneficial because normally we have a pattern of decelerating breathing. Whenever we start inspiration, we create a tremendous amount of flow initially, and then the flow falls down and goes into expiration. So maybe the flow pattern of a pressure control breath mimics more that of a flow pattern in a normal breathing. Just by looking at the graph on the ventilator, we know which mode the patient is on. One thing which remains constant is the inspiratory time. So in both pressure control and volume control mode, the inspiratory time remains fixed. The trigger can be made either by the patient or the ventilator depending on a time elapsed. But the flow pattern will vary, one being square wave and other being decelerating, and the pressure patterns will also vary. In one it will peak slowly, whereas in the other it peaks immediately, stays constant and then cycles into expiration.